These two structures are called the canonical forms, and the hybrid of it is called as the resonance hybrid, and this will be having the least energy than the highest stability. The polarity produced in a conjugated system as a result of interaction between two pi bonds or pi bond and a lone pair of electron is called as mesomeric effect. The groups which increase the electron density in the ring system and facilitates the electron substitution reactions are known as ring activating groups. Hello everyone, this is Ambli Unnikrishnan from the Department of Chemistry, Vidhyaashram Pre-University College, the Temple of Excellence, Mysore. So today we are back with session 7 of the chapter Organic Chemistry. So in the last session we discussed about nucleophiles. What are nucleophiles and what are electrophiles, right? And then we studied about the electron movement in organic reactions and also the electron displacement effects in covalent bond. Yes, we discussed the first electron displacement effect in covalent bond, that is inductive effect, in the last class, and we also studied what is minus I effect and plus I effect and the groups which will be showing this plus I and minus I effect. Yes, so in today's session we are going to study about the rest of the three electron displacement effects. The first one is electromeric effect, right? The next one is mesomeric effect or resonance effect, okay? Mesomeric or resonance effect, and the third one is hyperconjugation effect. Right. So let's begin with the first one, that is electromeric effect. So when does a compound shows electromeric effect? That is if the compound is having multiple bonds, that means double or triple bond, and if it is attacked by a electrophile, which is represented by E plus, right? If it is attacked by an electrophile, what happens is the pi electrons will be completely transferred to either of the one atom. So in general terms, I can write if there are two atoms A and B, right? And if an electrophile is coming and attacking onto this compound, that is to the double bond, what happens is this pi electron, yes, you can see there is one sigma and one pi electron, right? Pi bond is there. So this pi electrons, both of the electrons which is shared between these two, now will be completely transferred to either of the one atom. So if I'm saying that if it is transferred to B, how it will be? A plus and B you will get, and B will be getting the pi electrons, right? So B will get the pi electrons and will have a negative charge, and A will get a partial positive charge, right? Yes, the electron pair is gone towards the B atom, so A will be get positively charged and B will get the lone pair of electrons, that is the pi electrons, and it will get negatively charged. So this is called as the electromeric effect. Yes, that is when a compound having multiple bonds is attacked by a electrophile, yes, the pi electrons will be shifted completely to either of the one atoms. So now based on this, there are two types of electromeric effects. That is, the first one is positive electromeric effect, which is represented by plus E. Positive electromeric effect, and there is negative electromeric effect, which is represented by minus E. Right. So let's begin with the first one, that is positive electromeric effect. In this effect, the pi electrons of the multiple bond are transferred to that atom to which the reagent gets attached. Okay, so the pi electrons will be transferred to which atom we are considering here. So in positive electromeric effect, the pi electrons will be transferred to the atom to which the reagent gets attached. So what is the reagent here? It is an electrophile, right? So let's take this example. As you can see, there is a double bond here, and the electrophile is coming and attacking on this particular carbon atom. If the electrophile is coming and attacking on this carbon atom, yes, that means to which the reagent gets attached, to that carbon atom, the pi electrons will be shifted. So what happens is this pi electron will be shifted to this carbon atom because the electrophile is getting attached to this particular carbon atom. So as you can see here, now the two bonds already were there, right? Now the electrophile came and attached to this carbon atom and double bond became single bond, and this particular carbon atom will get the electrons, right? And hence that carbon atom is getting the electrons, the other carbon atom will be getting a positive charge, right? So this is the plus E effect. That is, the pi electrons will be shifted to that carbon atom to which the electrophile is coming and attaching. Right? Now what will be minus E effect then? In this effect, the pi electrons of the multiple bond are shifted to that atom to which the attacking reagent does not get attached. Right? So to the carbon atom to which the electrophile is coming and attacking, apart from that, the carbon atom which is present, to that carbon atom, the pi electrons will be shifted. So, as you can see here, again we have taken the example of an alkene, and if the attacking reagent is coming and attacking on this particular carbon atom again. Yes, but in minus E effect, this carbon atom will get the pi electrons. Right? In the plus E effect, the carbon atom which is getting attacked by the attacking reagent will itself get the pi electrons. In minus E effect, the other carbon atom will get the pi electrons. So as you can see here, the attacking reagent is now attached to this particular carbon atom, and the pi electrons is being shifted to this particular carbon. Right? So this is plus E effect and minus E effect. Right? Now moving on to the next effect, that is resonance effect, or you can also call it as mesomeric effect. So before understanding resonance effect, we need to understand what is resonance. Right? So as you can see, the phenomenon in which a compound is represented by two or more structures is known as resonance. So, as you can see in the case of benzene as well, there can be more than one possible structures, right? So, if it shows more than one possible structures, that phenomena is called as resonance, right? And each of that structure is called as resonance structures, and the hybrid of all those structures is called as the resonance hybrid. Right. So, the different structures of the same compound are known as canonical forms, and the actual structure is called as the resonance hybrid. The hybrid of all these structures together are called as resonance structure, and each of the different structures is called as the canonical forms. Right. Now, the resonance structures are not actual structures and do not represent any real molecule. So, these different structures, none of which can't be told as the actual structure of it. The hybrid will be the actual structure. Now, the resonance hybrid is less energetic and more stable. We know that if the energy is least, the stability will be more. So the resonance hybrid of all these structures will be having the least energy than all of these canonical forms, and the resonance hybrid will be having the highest stability and than any one of the canonical forms. Right. Now, resonance increases the stability of a molecule and decreases its reactivity. So, more the resonance structures, more will be the stability and least will be the reactivity. Right. Now, the energy difference between the actual structure and the lowest energy resonance structure is called as the resonance stabilization energy or resonance energy. So, the energy difference between the actual structure and the lowest energy structure is called as the resonance energy. Right. Now, let's take the example of benzene itself. As you can see here, the benzene, yes, the double bond is present here, here and here. Right. Another canonical form for this benzene, the double bond can come here, here and here. Right. There is a continuous delocalization of pi electrons. That means the position of this pi electrons can continuously change. Right. So, none of this canonical forms is the actual structure. So, to gather all these structures together, we use the resonance hybrid. So, how you can write the resonance hybrid? The benzene structure can be drawn with a round in the center. Right. So, that means continuous delocalization of pi electrons is happening. That means the double bond can occupy any positions together. We can draw it with a circle here. So, these two structures are called the canonical forms, and the hybrid of it is called as the resonance hybrid, and this will be having the least energy than the highest stability. Right. Now, the structure of benzene has 3 carbon-carbon single bonds having bond length 154 picometer and 3 carbon-carbon double bonds having 134 picometer. So, this double bonds you can see that is having, yes, how many double bonds are there? 3 double bonds are there. Now, these 3 double bonds are having a bond length of 134 picometer, and the single bonds between carbon and a carbon is having a bond length of 154 picometer. But experimentally, it was found that all the carbon-carbon bonds in benzene are having the same length, that is 139 picometer. It is neither 134 or 154. All the bonds in benzene, that is carbon-carbon bonds in benzene, is having the bond length of 139 picometer. And this could be explained using the above structure. Right. So this resonance hybrid, in the resonance hybrid, all the carbon-carbon bonds will be having the bond length, that is 139 picometer. It is neither that of double bond or single bond. So it is having bond length intermediate to both of that. Right. That is why it is resonance hybrid. Okay, clear? We understood what is resonance. Now we are going to study what is resonance effect or mesomeric effect. So the polarity produced in a conjugated system. Conjugated system means alternate double bonds will be laid. Like in the case of benzene. Yes, here you can see a double bond. The next position is single bond again. Then double bond, single bond, double bond, single bond. Alternate double bonds will be there. So that is called as a conjugated system. Right. So the polarity produced in a conjugated system as a result of interaction between two pi bonds or pi bond and a lone pair of electron is called as mesomeric effect. It involves the transfer of pi electrons or lone pairs of electrons to the adjacent sigma bond. Okay, mesomeric effect, what happens? The pi electrons will be transferred to the pi electrons or lone pairs of the electrons will be transferred to the adjacent sigma bond. Okay, so in the same way we have studied inductive effect and electromeric effect. Resonance effect also of two types. Okay, so the first one is plus M or plus R effect, that is positive mesomeric effect or resonance effect. So the migration of pi electrons or lone pairs of electrons away from the group or atom attached to the conjugated system is known as plus M or plus R effect. So such groups are termed as electron releasing groups. So in plus R or plus M effect, yes, the lone pairs or the pi electrons will be taken away from the group attached to the conjugated system. Okay, so the electrons will be transferred to the carbon atom. Okay, what does that mean? Electrons is taken away from the group attached to the conjugated system. Okay, so it is shown that the electrons will be taken away from the group attached to the conjugated system. That means taken away from the group attached to the conjugated system means, yes, the electrons will be given to the carbon atom. Right, so that is plus R effect. So as you can see here, the few examples or few groups which shows this plus R effect is chlorine, bromine, iodine, NH2, OH, OR, all these groups shows plus R effect. Yes, now they have lone pairs or pi electrons in them. So as you can see, X, it is generally written here. So they shift their or give their pi electrons towards the carbon atom. Right, as you can see, there is a carbon atom here. That is, electron is taken away from the group which is attached to the conjugated system. Or we can also say that the electrons is given to the carbon atom. So as you can see, again the resonance structures you can see. First the carbon atoms will be, first the lone pair of electrons will be shifted here. So this becomes a double bond. Right, so one pair of electrons is gone means this becomes positively charged. Right, and this particular double bond is shifted here, it becomes a negative charge here. Right, and this negative charge, when it comes to this position, a double bond is shown here. Right, and this double bond is shifted to this position, again a negative charge in para position. Right, and from here further the double bond is shifted here. So as you can see, again the negative charge will be here. Right, and the negative charge further shifted here, you can see the double bond will be in these positions. Right, so these are the resonance structures. So as I said, in plus R effect, the electrons will be given to the or moved, shifted towards the carbon atom, and it is away from the group which is attached to the conjugated system. Right, so the groups which increase the electron density in the ring system and facilitates the electron substitution reactions are known as ring activating groups. Right, and these groups direct the incoming electrophile to ortho and para positions, and they are called as ortho-para directing groups. So these groups which is attached to the conjugated system, they are ortho-para directing groups. Okay, so if in the benzene ring there is an halogen atom, that is chlorine, fluorine, bromine or iodine, they are ortho-para directing groups. That means if there is a reagent which is incoming attacking reagent, it will be either substituted in the ortho position, that can be these two, or else it will be substituted in the para position. right? So this is plus R effect. Now moving on to the next one, that is minus R effect. That is the migration of pi electrons or lone pairs towards the groups which is attached to the conjugated system. Right. So as you can see here, a carbon atom is here. This is the attached group here. Right. The attached group will take up the electrons, or the pi electrons or lone pairs will be moving towards the group which is attached here. Okay, so such groups or atoms are termed as electron withdrawing groups. Why they are electron withdrawing groups? They are taking up the electrons from the conjugated system towards itself. So the group which is attached onto the benzene ring will take up the electrons. Okay, so they are called as electron withdrawing groups, and this effect is known as minus R effect. Right. Now moving on to the next slide, groups or atoms which decrease electron density in the ring system are known as ring deactivating groups. They are taking up the electrons. They are withdrawing the electrons from the group. So they are called as ring deactivating groups. And these groups which direct incoming groups to meta positions are called as meta directing groups. So these groups which takes up the electrons, that is electron withdrawing groups, what do they do to the incoming reagents? They are directed towards the meta positions. So they are called as meta directing groups. And few groups which show this is nitro group, CN, CO, ketone, then aldehyde and carboxylic acid groups. Right. So all these are electron withdrawing group, and the ones which is showing plus R effect, they are electron donating or electron releasing group. Why? Because the electrons are being donated to the carbon atom. In these groups, the electrons are taken from the carbon atom. That is the conjugated system. Right. Now moving on to the last effect, that is hyperconjugation effect. So the delocalization of sigma electrons of carbon hydrogen bond of an alkyl group directly attached to the unsaturated carbon atom or an atom with an unshared p orbital is known as hyperconjugation effect. So in hyperconjugation effect, there must be an unsaturated carbon atom. Unsaturated carbon atom means either it is double bond or triple bond, and directly attached to it there must be an alkyl group also. Right. And now if there is an alkyl group which is attached to the unsaturated carbon atom, delocalization of sigma electrons takes place in the CH bond. Okay. So in hyperconjugation effect, what happens is the order of inductive effect will get reversed. So as you can see here, what happens is the delocalization of sigma electrons from CH bond takes place. So in the first structure, as you can see, it is an ethyl carbocation, right? So what happens is now this carbon is electron deficient, right? This carbon is a carbocation, right? So it is having a positive charge. Now this carbon is electron deficient. So what happens is this sigma bond undergoes delocalization. So what happens is this CH bond, right, now that will be transferred to this particular bond. There is a delocalization taking place and it becomes a double bond. So this bond is breaking and a double bond is formed here. So what happens here? The H plus atom will be there. Right. As you can see, there won't be any bonds here. Hyperconjugation effect is also called as no bond resonance. As you can see, there will be no bonds here. Now, what are the further structures? Further structures, it can be shown here as well as here. So these are the three hyperconjugative structures of ethyl carbocation. So as it is having no bonds, it is also called as no bond resonance. So what happens? The CH sigma bond will be transferred, that is the electrons will be transferred to the electron deficient carbon atom, and it will form a structure like this which doesn't have a bond here. So this is called as hyperconjugation effect. So I hope it is clear. Now more the number of alkyl groups attached to a positively charged carbon atom, more the number of hyperconjugative structures and higher the stability of ions. So more alkyl groups means more electrons will be there, right? So more electrons can be given to the electron deficient carbon atom. Carbocation means they are electron deficient, right? So the more number of alkyl groups, more will be the hyperconjugative structures and more will be the stability of the ion. As you can see, this is the methyl carbocation, this is ethyl, this is secondary and this is tertiary. So it will be in the order, tertiary will be having the highest stability. Yes, as it is having more hyperconjugative structures and more alkyl groups. There are 3 CH3 groups, right? CH3 thrice, 3 CH3 groups, more electrons to transfer to the electron deficient carbon atom. Order of stability, methyl, primary, secondary and tertiary carbocation is explained on the basis of plus I effect and hyperconjugation effect. So as you can see, when we consider this is a tertiary carbocation and this is a secondary carbocation, right? Why it is tertiary? To the carbon atom containing the positive charge, 3 more carbon atoms are attached. So it is tertiary. And here 2 carbon atoms are attached. So it is secondary. So when we compare the tertiary and secondary, more alkyl groups are present here. Hence tertiary is greater than secondary. Tertiary carbocation will be showing more hyperconjugation effect than secondary carbocation. So now moving on to the next concept, that is type of organic reactions and mechanism. So the organic reactions can be classified into 4 types. The first one is substitution or displacement reaction. In a substitution reaction, an atom or group present in the substrate is replaced by another atom or group. So we know that substitution means what? Instead of one person, another person will take up that position. So in the same way, whichever group is present in the substrate is being replaced by another incoming substrate. Right. So let's take the example here, CH3Cl. What it is? Chloroethane. Right. Chloroethane, when it reacts with sodium hydroxide and when it is heated, what happens? The chlorine will be, yes, replaced by the OH minus in sodium hydroxide. Right? Yes, what happens? Cl is negatively charged and OH is also negatively charged. They will be substituted with each other. So what happens? You will get methanol and the Cl will be now attached with the sodium. So you get sodium chloride. So this is substitution. Instead of the atom which is present in the substrate, another. So in substitution reaction, instead of the atom which is present here, another incoming reagent will be replaced, right? Now addition reaction. In an addition reaction, atoms or groups are added to the unsaturated system. So as you can see, unsaturated system, ethene is taken here. When hydrogen is added to it in presence of nickel and in 180 degrees Celsius, what happens? Yes, it becomes ethane. It is becoming ethane. What happens to the double bond? The double bond will become single bond, right? The double bond becomes single bond. Right? So addition of hydrogen is taking place. That is 2 hydrogen atoms is extra added. It will be CH2 double bond CH2 and your ethane is CH3 CH3. Right? Now moving on to the next type of reaction, that is elimination. Someone is being removed, right? So in elimination reaction, 2 atoms or group of atoms are removed from same or adjacent carbon atoms in a molecule. So as you can see, it is chloroethane which is taken, CH3, CH2, Cl. And if it undergoes reaction in presence of alcoholic KOH, what happens is, yes, the Cl and 1 hydrogen atom will be removed. Dehydrohalogenation takes place. 1 hydrogen atom and chlorine atom will be removed and you get ethene and KCl and water. Okay, so the removal of atoms or a group of atoms is called as elimination reaction. The next one is rearrangement reaction. In rearrangement reaction, migration of an atom or group of atom from one atom to another atom within the molecule is called as rearrangement. Rearranging means within a molecule, the atoms or group of atoms are being rearranged. So as you can see, 1, 2, 3, 4, 5. It is normal pentane, right? So when it undergoes reaction in presence of anhydrous, AlCl3 and heat, what happens is, yes, this one CH3 groups comes and attaches to the second carbon atom. So what happens is, even though the number of carbon atoms are same, the structure is different, right? The molecular formula is same, the structure is different. So what happens is, inside the molecule itself, rearrangement is taking place and the CH3 group will come and attach here. Right? So this is called as rearrangement reaction. So I hope the different types of reaction is also clear for you. That is substitution reaction, addition reaction, elimination reaction and rearrangement reaction. So in addition reaction, as you can see, double bond will become single bond, right? And in elimination reaction, single bond will become a double bonded system. Right, and then the last one is rearrangement reaction. So I hope the different electron displacement reactions as well as the different types of organic reactions is clear for you. So in the next session, we will be studying the different methods of purification of organic compounds, right? So we'll be studying distillation, sublimation, crystallization, differential extraction and chromatography in the next session, that is different methods of purification of organic compounds. So I hope what and all we have discussed in this session is clear for you. So that's all for today. Thank you.